This is the 1997 multiple choice calculator questions. So in the year 1997, the number of questions on the no calculator part and the calculator part were different. The College Board has changed the number of questions on each part throughout the years. But either way, the questions are good, and the purpose of this video is just to walk through these calculator problems, look at a variety of problems, and as you can see, the work that we are doing is important. So I'll be showing you some calculator usage and hopefully getting you more proficient with that. All right, so if we go to the next page, so just do it, get it, do it. 0 to 5, if you integrate that, guess what you get? A 5. All right, so in this particular year, in 1997, there were 40 minutes on this, and I believe it's 17 questions. The exact numerical value of the correct answer does not always appear among the answer choices. When this happens, select from among the choices the number that best approximates the exact numerical value. The domain, unless otherwise specified, is assumed to be all real numbers. So in our folder, you will find a copy of what you're seeing right now. It has commentary with pretty detailed explanations and workouts of how to do the work. So I'm not going to work these problems. I'm just going to go through and highlight some that might need some support. I think for the most part, you can probably follow the work that I've posted in the folder to understand these questions. Another thing we're going to talk about is in each question, analyzing, is this a calculator question or not a calculator question? Not every question in the calculator part requires or can even use a calculator. So in number 76, you can see that they're giving us a function. It is a quotient, and they want us to find the derivative. They're not asking us to find the derivative at a particular value, so this is not a calculator question. It requires the quotient rule, and within the quotient rule, you're going to need to use the chain rule. Remember, the derivative of e to a power is good, e to the power times the derivative of the power. So here I'm showing the quotient work, down, d up, minus up, d down, over down, down. And then it's a matter of cleaning and matching my answer to their answer. So you see right here, I have a common factor of 2e to the 2x in the numerator. And so I'm going to need to clean or factor out that 2e to the 2x to match my answer with their answer. So you have to do the derivative by hand, you have to watch the quotient rule, and you have to be careful of taking the derivative of e to the power. The answer is e. Number 77. In number 77, the graph of the function, and they give us a cubic, changes concavity at. Now, there are two ways to look at the concavity change. Remember from the All About Me sheet that you can use, if you have a graph, you can use the first derivative to determine whether a concavity changes, or you can also use the second derivative. So I'm going to graph the first derivative, and I'm going to, wherever the first derivative has a local extrema, local max or local min, the original function has a point of inflection, meaning that it changes concavity. So make sure you are very familiar with the All About Me sheet. If you haven't studied that, that's going to be huge on the AP test. So y is equal to x cubed plus 6x squared plus 7x minus 2 cosine x. The first thing you want to be careful of when you're dealing with the calculators, make sure you have typed that thing in correctly, because obviously that's going to make a big difference in your answer. Secondly, the disclaimer is I know that some of you have different calculators that operate a little bit differently than mine, but in general they operate similarly, and in your resource packet you will find probably 3 or 4 pages. I'll have to pull the reference packet and maybe we'll just walk through that and see what's in there, of how to use every and any calculator to do whatever it is you need to do. All right, so in this one, I said I was going to graph the first derivative, so I'm going to go back to the equal marks, and I'm going to turn the function off by de-highlighting that equal marks. And so if you look right here, the equal marks have been unhighlighted, and I'm going to go to y number 2, and I'm going to tell the calculator to take the derivative, so that would be a math 8. I want the calculator to take the derivative of the function in y1. So I'm going to call up y1, however your calculator does that, in terms of x at every value of x. Now when I do my graphing, since this is a trig window, I'm probably going to do a zoom 7. Do they give me a window? Well, I have my answers to know that the answer is going to be somewhere in this little negative zone, so I'll probably just do a zoom 7, and I should be able to see what's going on. If not, I'll adjust my window. And looking at the answer choices, I can see that there's going to be a local minimum somewhere down here, so I need more y minimum. So I go to the window, once it's done graphing, window, and I'm going to do the y minimum to -20 just to be on the safe side. And I'll change the y scale to go by 2s. You don't really have to do that. All right, I'm going to wait for the calculator. And there is the minimum that I am looking for. Got to wait for the calculator to finish its work. And so I'm going to do a second calc. I'm going to select the minimum, 3. I'm going to move the cursor on the left side of the minimum, enter, to the right side of the minimum, enter, and I don't want to guess at my answer, so I see that the answer is going to be -1.89, which is D. Number 78 is a no calculator question, and it is one of the most missed questions on this set. So let's take a look at it. Mostly it's about reading and being really, really careful. All right, the graph of f. Make sure you know what you have a graph of. The graph of f is shown on the figure above. So this is f. Now I've already color-coded mine. If the net area, notice how I'm reading that. I'm not saying the definite interval. If the net accumulated area from 1 to 3 is 2.3. So if you look at the way I've highlighted, the blue and the yellow together make 2.3. And big F prime of x is equal to f of x. So what they're saying here is that f, this function right here, little f, is the derivative of big F. So if I anti-differentiate little f dx, I will get big F of x. So they want me to evaluate that from 3 to 0. So really they're saying we just want you to do the integral from 0 to 3. Oh, and I apologize. I realized I just misspoke something just a second ago. The net area from 1 to 3, I apologize, is in yellow. That is the 2.3. So let me make that clear. The net area from 1 to 3, which is yellow, is 2.3. So what they want me to do in the problem is to find the net accumulated from 0 to 3. So that's why I've highlighted it in different colors. I've highlighted this in blue. Notice that these are squares that are 1 by 1. So this is a net accumulated area of 1. This is a net accumulated area of 1. Added to the 2.3 in yellow gives me a total of 4.3. And again, you can read my commentary in the notes if you want to spend more time with this. Most of these are pretty clearly explained in the commentary, so I think that's really helpful. Number 79. So in number 79, hopefully when you looked at that thing, you said, I bet that's definition of derivative, and you would be right. So if you look at the commentary, this is the definition of the derivative, and you have to be able to recognize it. You're told, what they're really telling you in this case is that the derivative of some function f evaluated at 2, so it's a point-specific derivative. So the derivative of f at 2 is 5. So right here, that's really saying f prime of 2 is 5, but they're putting it in the form of the definition of derivative. And we want to know if f is continuous at x equal to 2. Well, in order for there to be, so if we look at the commentary here, there is a derivative, so therefore the function is differentiable, and differentiability guarantees continuity. So we know that the function f has to be continuous at x equal to 2. It has a derivative, so it's certainly differentiable at x equal to 2. And then third says is the derivative graph. Think about, do I know about the graph of the derivative of f? Well, not really. All I know is that the derivative at one value of x, at x equal to 2, is 5. So I really don't have any way of knowing that the derivative of f graph is continuous or not. So the answer is guaranteed 1 and 2, which is letter C. In number 80, a railroad track and a road cross at right angles. So this is our classic Pythagorean theorem, and it's going to be a related rate, ladies and gentlemen, and it's not a hard related rate. Pythagorean theorem related rates are pretty easy. So the first thing it's important to do is to sketch a graph and record the information. Reading is the most important thing. So I have the graph down here, so hopefully you're looking at your paper. You can read that while I am pointing out information. So it says in number, I lost my number, 81, a railroad track and a road cross at right angles. So here's my railroad track and here's my road and there's my right angle. An observer right here, he's happy, is standing 70 meters south of the crossing. So this is the 70 meters between the railroad track and the observer. He watches an eastbound train, so the train is going eastward, at 60 miles per hour. So you're going to have to choose your variables. I chose x for the horizontal distance. I chose z for the distance between the observer and the train. And the 70 meters is fixed, so I am not going to make that a variable. That would be a tragic mistake. So since the train is going in the x direction, the rate of the train is dx dt, 60 meters per second. This is me recording everything out of the problem. At how many meters per second is the train moving away from the observer? So this is the distance between the observer and the train. So it's asking us to find dz dt when t is equal to 4. So we start with our classic Pythagorean theorem that connects the x and the z. So x squared plus 70 squared is equal to z squared. Implicit differentiation, take the derivative, 2x dx dt. The derivative of that constant is 0, 2z dz dt. So we know that the time is equal to 4. So if we want to know the distance traveled by the train, we're going to multiply the 4 by the 60 to give us the 240, what were the units? I've already forgot. Meters, 240 meters the train has traveled at dx dt, which is 60 meters per second. And then to figure out how far the train is from the observer, we're going to have to use our Pythagorean theorem. So we know we have x squared plus 70 squared is equal to z squared. We already know that x is 240, so with our calculator, I'm not going to show you that, I know you can handle that. We're going to find out that z is equal to 250. We're going to substitute. We're going to let the calculator do its job. We're going to multiply and divide by 250, and we get 57.6, which is letter A. So if you did not get that right, go back and redo the problem and force yourself to do a related rate, even though you've heard me explain it. Make sure you can get it. In the set, number 82 is also a kind of a missed problem. It's so simple, students get all confused by it. They give me a function, y equal to 2x minus 8, so we have the equation of a line. What is the minimum value of the product of x, y? So the reason that students get confused by this, I think, is it's an optimization problem, but it's not, I guess, hard enough or confusing enough. They're literally telling us that we're finding the product of x, y. So if you look right here, I'm going to minimize the product x, y. But I can substitute, I already have my helper equation of 2x minus 8, so I can substitute 2x minus 8 in place of this y. So if I do that, that gives me x times 2x minus 8. And then with my calculator, I don't even have to multiply that through. If I want to be lazy and not make it 2x squared plus 8 minus 8x, I can literally type this into my calculator, and I'm trying to minimize this product. So I go to the calculator and I find the minimum. I don't even have to do any calculus on that problem. So if you're wondering what I'm talking about, or if you're not sure, on the calculator, I'm going to clear out what I had before, and I'm going to put in x. I'm going to do it lazily. I'm not going to multiply together. 2x minus 8, zoom 6. And they want us to find the minimum of that parabola, which is the vertex. So I'm just going to use the feature on the calculator to find the minimum, and I'm done. No calculus involved. I didn't take a derivative or anything. Number 83. What is the area? This is something recent for us. In the first quadrant, so pay attention to that, enclosed by the graphs of y equal cosine x, y equal to x, and the y-axis. So let's take a look at what that region looks like. So I have cosine x, and I have y. Whoops, not in the window. And I have y equal to x, and I'm going to do a zoom trig, which is zoom 7. And I'm only interested in the first quadrant. I'm not going to do a zoom box or change the window because I can see the first quadrant here. So remember, to find area, we're going to do top minus bottom. And so we're starting at an x value. Oh, let me make sure. Wait, we'll be careful. I know what I could have done here. It's also bounded by the y-axis. That's really important because we have this region right here and we have this region right here. This region's bound by the x-axis. This region's bound by the y-axis. So that actually would have made a difference. You could have gotten your problem wrong by thinking that this was the region that we find the area of instead of this one. So it's bounded by the y-axis, so it's this little region right here. We're starting at 0. You can validate that with your calculator. And then we're going to need to find this point of intersection, second calc 5. And the expectation is that you would store that. And the directions for storing, if you don't remember how to do that, are in your resource packet. Everything you would ever want to do on your calculator, you can find out how to do in your resource packet. And then I'm going to do top minus bottom. So I'm going to go second quit. Oh, I don't have to. Math 9. The function is top, which was cosine. Vars, y bars, function, y1 minus vars function. Again, your calculator may operate differently, and that's fine. From 0 to alpha a. Oops, did I miss a comma? Whoops, sorry here. Comma 0 to alpha a. And I get 4.004, which is basically 4.00, which is C. Number 84. The base of the solid of a region enclosed by the graph of ln x and x equal to e. Now remember, we don't graph vertical lines on our calculator. We just know that e is approximately 2.71 blah, 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 almost 3. Cross sections are perpendicular to the x-axis, so we're in terms of x, and the cross sections are squares. So area is equal to side squared, so the side. Again, commentary's on here, so you can, whoops, oh, sorry. Sorry, I hit the little thing that's holding the camera. So if we look at this one, clear and clear. So we had, I think we probably, this seems like one we've done in class before. Ln of x, not sine of x. Close and zoom 6. Looks like that. And so if the graph looks something like this, and then we have x equal to e right here. So the square is top minus bottom. So the length of the square, the s, is going to be the square root of ln of x. And then you can write your integral. So because your integral is going to be from, and you're going to have to figure out what this value is. So you can use your calculator to find out that that's 1 to e. There's no pi. We're doing side squared. So we have square root of ln of x squared dx. And if you square the square root, you just get ln of x. You go to your calculator and you'll get a volume of 1. So that's number 84. Oh, a little text that I got from someone, or a picture of a text. Hey, what did we do in math today? Review calc. Got to know your stuff all the time. What's the most important thing? Reading, reading, reading. Okay, back to work. So number 85. If the derivative of f is given by, so they're giving us a derivative straight up, which of the following values of x does f have a relative maximum? So we want relative maximum of f. So that's where f prime, all about me sheet, study, study, study it. F prime of x changes from positive to negative because we're looking for a relative or a local max. So all we're going to do is graph in the derivative function that they give us here. Clear. And so that would be e to the x minus 3x squared, and zoom 6. Again, looking at your answers to know about the range or the vicinity where the answer is going to be. I can see that the graph of f prime changes from positive to negative at this value. Just a reminder, I think it's way easier, and I strongly, strongly encourage that you put in y equals 0 as the second function so that you don't have to left and right bound. Sometimes that causes a lot of problems for some students. So second calc 5, enter, enter, and we get 0.910, which is answer C. 86. Let f of x equal square root of x if the rate of change of f. So rate of change of f means f prime of x. Down here, let's see if I'm getting that on here. F prime of x, or f prime of x at c. Now notice, watch me reading the words. It's all about the words. If f prime of x at x equals c is, so equal, I'm just doing literal translation, twice, that means 2 times, its rate of change at 1, f prime at 1, then c is equal to what? So this is really a pretty easy problem if you do the translation. So the derivative of the square root of x is, f prime of x is 1/2 x to the negative 1/2 power, which is the same thing as 1 over 2 square root x. So I come over here and I have 1 over 2 square root c. On the right hand side, I have 2 times 1, which is 2, over 2 square root 1. 2's divide out, the square root of 1 is 1, so I have 1 over 2 square root c equal to 1. Cross multiply, and I have 1 equal to 2 square root c. Divide by 2, and I have 1/2 equals square root c. Square both sides, and I have 1/4 equal to c. I hope that showed up all on the yes, yeah, now it is. Okay, so that's really an easy question. I guess you could use your calculator to do that. You could make your calculator, I guess, could you? Maybe a little bit. I don't know. I just can't really see that being much of a calculator question. But anyway, another thing that I want you to notice in the problems is that just because I do a problem a certain way doesn't mean it's the only way to do a problem. Sometimes there may be easier ways that I just don't even pay attention to. So it just depends on how I look at the problem at that particular time. So number 87, at time t equals 0, the acceleration of a particle along the x-axis is given. So we have an acceleration function. At t equals 0, the velocity is -2. So we have an initial condition for velocity. So that's really v of 0 equal to -2. For what value of t will the velocity of the particle equal 0? So we're going to find the antiderivative of acceleration. So the antiderivative of t plus sine t, that gives me t squared over 2 be careful, the antiderivative of sine. So let's think about this. The derivative of cosine is negative sine. So the antiderivative of positive sine is negative cosine of t plus c. And we have an initial condition. Remember back here, v of 0 is negative 2. So I have, substituting 0 here, I get 0. The cosine of 0 is 1 plus c is equal to, was that negative 2? Yes, negative 2. So c is equal to, add 1 to both sides, negative 1. So that gives me t squared over 2 minus cosine of t, I lost my place, minus 1 is my velocity function. And we want to know, sorry about that, when that's equal to 0. So we're going to type in our velocity function in y1. So this would be y number 1. When you type in 1/2 t squared, type it in as 0.5 t squared. That way you don't have to worry about parentheses or not parentheses. Type that into y1 and type this into y2 and find the point of intersection using your calculator. Okay. In number 88, so now we're back to all about me sheet. You'll notice that's a big theme of this test. We have f of x given to be a definite integral where h is the graph shown above. So this is the graph of h up here. We know from the FTC part 2 that f prime of x is equal to h of x. That's FTC part 2. Which of the following could be the graph of the original function f? So this is the graph of the derivative. So the first thing I'm going to look at is that the derivative graph changes from positive to negative at b, telling me that there is a local maximum at b. So it can't be b because there's not a local maximum at b, or in this graph on b. It can't be c because there's no local maximum here. It can't be D because there's no local maximum here, so it's between A and selection A. I don't think you can see these in the window. Sorry about that. C and E, which is down here. So the next thing I'm going to do is come back up to the derivative graph, and I notice that in this region, the derivative is positive, meaning that the graph increases. And in this region, the graph is negative, meaning that the graph decreases. So here we have increase to the local maximum, and then a decrease. And then here, let's see, what rules out A? Well, the derivative graph is smooth, so it's not going to create a sharp turn. Well, here's one thing we can look at. There is a local max on the first derivative, so there is a concavity change prior to the y-axis. And here, the concavity change is about here versus the concavity change is right in here. So that kind of rules E in. So you could use that concavity to help rule that out. And again, you can read the commentary for some more details. Number 89, we've got two more. Number 89, a table of values is given for a continuous function. If 4 equal subintervals from 0 to 2, and we're using the trapezoidal rule to approximate the net area, so we're 4 equal subinterval, did it say equal? Whoa, 4 equal. So we know we have a common height in this case of 1/2. So we're going to break the region into 4 parts, and we're going to do the trapezoidal rule, write it up, and calculate it carefully on your calculator. This is such an easy problem. Just make sure that you type correctly and you don't do something silly, because you just don't want to lose points on something as easy as this trapezoidal approximation. And then lastly, question number 90, which of the following are antiderivatives of f of x equals sine x cosine x? So in other words, if I find the antiderivative of sine x cosine x, which could be done, but I don't think it's the easiest way to do, and I don't think you actually can find the antiderivative in this case of f of x. So instead of finding the antiderivative, take the answers and find the derivatives to see which one of those give you sine x cosine x. So you can see my work here. I'm not going to recreate it for you. The 1/2 is a coefficient, so I'm really just finding the derivative of sine squared x, which by the chain rule is 2 sine x cosine x. 2's divide out, and you get sine x cosine x. So that is one of the answers. For the next one, you do the same sort of thing with the chain rule, and you get negative sine x cosine x, so that is not one of the answers. And then for the last one, again, that 4 of a coefficient, 1/4 coefficient comes out front, and you're going to use the chain rule again. The derivative of cosine is negative sine of the angle times the derivative of the angle. And this one, there's a little bit tricky here. When you reduce, you get sine 2x, and you do kind of have to remember that sine 2x is 2 sine x cosine x in order to get that other answer. So, hope this was helpful to you. I will be posting more videos soon.